Right. So hello everyone, welcome to Sydney. Such a nice place here, so I hope you enjoyed the summit. So and in this presentation we're going to talk a little bit about self-healing, about fault management in real like systems. And we are Nokia employees. My name is Ronat Akhmerov. I work for Nokia as an engineer, and here's my colleague Ifat. I'm the Mistral PTL. Ifat is the Vitrage PTL. So, and let me actually start. So, when we're talking about real-world systems, it's actually a natural thing when we get some errors once in a while in the system, and maybe not even once in a while, but pretty often, and we have to deal with them somehow. So it's real life. And for example, when a failure happens, it's often to easily see symptoms of this error. So something just doesn't work, but it's not easy sometimes to detect the root cause and actually fix the problem. So, and today we're going to propose one of the possible solutions using the tools that are available within the OpenStack community, and it's going to be Vitrage and Mistral. So now Ifat is going to show you a quick demo, and then we'll talk more about Vitrage and Mistral, why they are useful for solving this problem.
Hi, so I'm going to show you a demo of a real failure that happened in the system, and I'll show you how Vitrage and Mistral are handling this failure. So suppose we have a nick down, which could happen, and in this system, it means that there is no network connectivity to the host. The host is down, the instances are down, and there is a heat stack that is using one of these instances. So the heat stack is also affected. And we'll see how it is managed by Vitrage and Mistral. So in the first step, we will see Zabbix. Zabbix is a very common monitoring tool that is used by Vitrage, and Zabbix detects that the nick is down, and Zabbix notifies Vitrage. And Vitrage identifies that if the nick is down, it means that the host is down, the instance is down, the heat stack is affected. And in this case, Vitrage asks Mistral to execute a workflow with corrective actions, and Mistral is asked to migrate the VM. One of the VMs that is used by the heat stack is migrated to a different host. So Mistral calls Nova, asks to migrate the VM, verifies that it worked properly, and then Nova notifies Vitrage that the VM was migrated, and actually the state of the VM and the state of the heat stack are recovered, and everything is working properly. Okay, so let's do the demo. I'll start with a quick overview of Vitrage UI. This is the topology view. It's a dashboard of the compute status. You can see the availability zone, the Nova hosts, and the outer ring is the instances. And you can see that everything is green. The system is working well. I can drill down to the host and see that there are no alarms on the host. Next, there is the Vitrage alarms view. In this view, we show alarms coming from different monitors like Zabbix, Nagios, CollectD, AODH, and right now there are no alarms in the system. And let's go to Vitrage entity graph. This is where we see all the resources that are collected by Vitrage. Vitrage collects resources from different data sources, OpenStack components like Nova, Neutron, Cinder, Heat, and also alarms from external monitors. And all of this information is put into one topology graph where you can see resources from the physical layer, the virtual layer, the application layer, how they are related to one another, and how they affect one another. Over here, you can see the Nova host, and you can see some properties of this host. You can see Nova instances and the heat stack, and you can filter by a specific heat stack to see just the most relevant information. Yeah, it will be in a minute. OK, so actually, we didn't see it. But now I'm going to bring down an interface and cause a real failure in the system. And we are going to see Zabbix. Zabbix detects that the interface is down and immediately notifies Vitrage about this failure. And if we go back to Vitrage entity graph, we see that there are many errors in the graph. A large area became red. Some resources are in error state. The host is in error. And actually, Nova is not aware of the problem with the host. Nova is not monitoring the host. And Vitrage is notifying Nova that the host is down. And the host is in error. And the heat stack is also in suboptimal state. This is all done by Vitrage. And now you can see only this heat stack with the resources that are most relevant to it to better understand. And you can also filter you can change the detail level and see some more details. And I think this is a good time to move to the alarms view, where you can get some details about the alarms. And here you see all of the alarms in the system. And most of them were raised by Vitrage. There is only one single alarm that was raised by Zabbix. And if we can open the root cause analysis view for this alarm, and we get a very clear picture of what just happened. There was an alarm detected by Zabbix. That's the uppermost alarm. And it caused a problem on the host. The host is down. And this problem caused all instances to be down. And the heat stack is also affected. And you can clearly see the root cause of the problems and all the affected resources. So this gives the cloud administrator a very clear picture. And now the business logic exists in Vitrage Templates. So Vitrage Templates, which we will see in a minute, these are YAML files, human readable, very easy to understand and to edit. And they determine conditions and actions when it's the right time to modify state of an object or to raise an additional alarm or to mark causal relationship. The interesting part of the template is the scenarios. And an example scenario is if there is an alarm on the host and the host contains an instance, we would like to set the state of the instance to error and to raise an alarm on that instance. Another template that exists in this setup is for executing a Mistral workflow. This is where the integration is determined. Here we say that if there is a heat stack that has an instance and the instance is down, we would like to execute a Mistral workflow that fixes the problem. Asks Nova to migrate the VM to a different host. OK, now we are going to see the Mistral UI. This is the Mistral new UI that was developed in Pike. It's called Cloudflow. And you can see over here the list of the last executions of workflows that were done by Mistral. The last one was called by Vitrage. And you can see here a list of tasks that the workflow performed. Because migrating a VM takes time, it might fail. So it's not enough to ask Nova to do it. Mistral also tracks the progress and makes sure that everything worked well. This is the workflow definition. And we can go over the task. The first task is to call Nova and ask to migrate the VM. You can see here the input and output of this task. The input is the VM that was down and was part of the heat stack. This is the VM we asked to migrate. Then there is a task, wait for the migration to happen. And this uses the Mistral capability to do retry for actions. And you can see soon that it retries quite a few times until the migration is finished. And we will see the task definition. And here we see the number of times to try and the delay between retries. And it waits for the status of the VM to be other than resize or verify resize. And once this is finished, we would like to make sure that the status is active and not error. So this is the next task. It checks again, the input is the same VM as before, and the output is that it gets information from Nova about the server and verifies that the state is active. OK, so this is the output, and you will see that the state is active, so the task succeeded. Then the next task is very trivial, to get the IP of the VM in order to later try to SSH into the VM and verify that it's well. And here this task failed because in this specific setup, there was no network connectivity to the VM. And you can see that Cloudflow also shows failures with all the information, so you can understand why a task failed. And of course, the VM migration succeeded, just we failed to SSH because of a technical problem, but the VM was migrated to the new host. And now I'll go back to the presentation. And actually, what I showed you in the demo was very slow motion of what actually happened, because I wanted to go through all the UI menus and show you the root cause analysis and everything. But actually, as soon as Vitrage identified that the VM is down and the heat stack is affected, it immediately asked Mistral to migrate the VM. And once the VM was migrated, some of the alarms went down. So after all of this happened, and it was faster than what you saw, this is how the graph looked like eventually. And this specific instance used to belong to the affected host, to the host that is down, and it was migrated to the other host, and Vitrage graph was updated accordingly. And the heat stack is also OK now. Both of them are in valid status, and the alarms went down. There are alarms only on the other instances. OK, so how did the demo work? The demo combined two projects, Vitrage and Mistral. Vitrage is responsible for providing insights about the system. It's not a policy engine, or it doesn't execute actions. And Mistral, on the other end, is a workflow service that is used to execute tasks. And together, they can do both analysis of the system and take corrective action. It's a very powerful combination. And in this demo, we saw how Zabbix notified Vitrage about the failure. Vitrage updated its state with the NIC failure and created additional alarms on the host, on the instance, and on the heat stack. Then Vitrage asked Mistral to execute a workflow with several tasks for VM migration. Mistral asked Nova to migrate the VM, then waited for the migration to finish, verified that the status is OK, and tried to SSH to the VM. Then, as soon as Nova finished the migration, Nova notified Vitrage that the VM was migrated. Vitrage updated its graph and removed some of the alarms that were no longer relevant. Now I'm going to take one step back and do a very quick overview of Vitrage, just in case it's missing. So Vitrage is an official project in OpenStack. It was started 2 years ago and became an official project 6 months later. And it's responsible for root cause analysis, but not only that. So in case of a severe failure in the system, there could be a lot of alarms, and Vitrage will help the cloud administrator understand what exactly happened and what is the root cause. But on the other hand, there are cases where not all resources are properly monitored. And in this case, Vitrage will raise additional alarms and update the states of the resources in order to give really a complete and correct view of the system. And now I'm going to drill down into the details of how Vitrage implemented this specific demo. So as we said, Zabbix notified Vitrage about the failure. And Vitrage holds an entity graph with the updated state of the system. So Vitrage updated the failure in the graph. Other than the entity graph, Vitrage has an evaluator component. The evaluator is responsible for evaluating changes in the graph against templates like you just saw in the demo. And Vitrage evaluator checked if there is a template that matches a case where the NIC is down and the NIC is attached to a host. And there was such a template. And when I'm saying evaluating the template, actually for each template YAML file, we generate small graphs. So we have a graph with a NIC that it's in error, and it's attached to a host vertex. And then we run subgraph matching algorithms, and we look for small subgraphs in the big graph. And for every such small subgraph that we found, we execute the actions according to the templates. So in this case, the evaluator asked the graph to set the host as down. And similarly, it asked the graph to set the instances state and update the hit stack state. And then the evaluator, once again, checked for matching templates. And there was a template that says that if there is a hit stack that one of its instances is down, there is a need to notify Mistral. And this was done by Vitrage notifier. It asked Mistral to execute the workflow. The parameters of the workflow are defined in the template. And Mistral asked Nova to migrate the VM. And Nova updated Vitrage. Vitrage updated the graph. You can see that one instance moved to a different host. And then the alarms and the state of the instance and the hit stack were updated because the evaluator found out that there was a template that said that the VM and the hit stack should be affected, actually 2 templates for this. And these templates are no longer relevant because the VM no longer belongs to a failed host. So the template was undone. And the undo action is to remove the alarm. So that's it about Vitrage part. So now back to you, Nat.
Thank you. And now I'm going to tell you a little bit about Mistral part of the story. So some high-level information in case of some of you don't know much about Mistral. So basically, and then I'll try to explain why exactly Mistral. Why is it so important in this particular scenario? So Mistral basically is also an official project in OpenStack community. It's been around for like 4 years now. And basically, this is a workflow service that allows you to design declarative workflows, run them, manage them. And it's based on a relatively simple YAML-based workflow language. And it also has REST API, of course, like all other OpenStack services. And basically, regular usage of Mistral, basically when you upload a workflow definition to this service, and then you say to Mistral, okay, I want to run this workflow. And from now on, it's responsible for the workflow execution, for all kind of, for mitigated all kind of possible failures that may happen with the workflow execution, because it's a distributed process. It's the workflow service itself may be hosted on a number of machines. It also allows you to design how your data actually flows through your process and how it gets transformed from one task to another. And it also supports things like task execution policies. Like, for example, you saw in the demo that one of the tasks was just waiting until the VM is fully migrated. And for that particular purpose, we used a task policy called retry. So essentially, it's needed for things like, I know that my task may fail at some point, and I know that the failure may be related to some temporary reasons, like the network is unreachable or something else, and it makes sense to retry it a number of times, checking certain conditions, and so on. And what's also important about Mistral is it can work basically like a glue, wiring different OpenStack services together within one scenario, providing the state management for this big process, and a single execution and authentication context. So basically, once we design the workflow, we can hit any OpenStack service without having to authenticate individually to every service. So this is like a very big picture about what Mistral is. And we already actually saw before that Ifat showed in the demo some workflow definition snippet, and I'm just briefly going to tell you what it is. So basically, it's YAML. Here we see the definitions of these tasks that we showed before. The first one is basically just to send a signal to Node to start VM migration process. But it's not enough, of course, because we need to wait till the VM is fully migrated, and we have another task. And basically, this particular workflow type is based on transitions. The first task says, okay, if it's successful, we need to go to the next task, which is wait for VM migration. And the second task, like we said before, has a retry policy applied to it. So, and a couple of words about Cloudflow, which is a standalone GUI. It was actually open sourced during the Pike cycle. And Cloudflow is a monitoring tool for Mistral workflow execution. So right now, we can't use it for building workflows, for designing workflows, but it's already a really useful tool for monitoring workflow execution. So once we started the workflow execution and we want to see what's going on with this workflow execution, we can use Cloudflow. It's a really good tool for that. And it actually fully reflects Mistral API data model, so it's smart enough to draw all kinds of workflow topologies, no matter what we use in those workflows, like join operations, multiple branches, parallelism, data collections, sub-workflows, and so on. So, and in our particular demo scenario, the workflow was relatively simple. It's just a simple sequence of tasks where, like, the next task runs only if the previous one is successful. But Cloudflow can do much more. It can draw something like this, and this is only like the relatively small piece of the real workflow. And it's also useful for huge things like that. And I just want to thank the guy whose name is actually Guy, who developed Cloudflow. It's our colleague from Nokia. Yeah. Now, basically, I just want to say a few words about why it is exactly important to use Mistral in in such a scenario? Well, imagine if we don't have anything like Mistral. So what would we do to mitigate the problem that was detected by Vitrage? By the way, I think as far as Vitrage, I think it's pretty obvious why it's useful, because I personally don't see any alternatives to Vitrage in terms of providing the comprehensive view on in what state our system, our whole environment and infrastructure is now on. So basically, something happened and we don't know what exactly and how all these things are related to each other. If something goes down in the infrastructure, we need to see how it affected all the upper level entities like heat stacks and whatever. But what about Mistral? So, for example, we don't see anything like Mistral. So probably the solution would be just to have like a number of scripts, no matter shell scripts, Python scripts, or something else, to fix all kind of possible problems. But it's not really good, because you would have to pre-deploy all these things in the environment, in your cloud environment in advance. And there's no flexibility in that. So basically, once you find a new situation that might happen in your environment, you need to redeploy something again. And it's not really flexible, it's not really configurable. And from that standpoint, Mistral really fits well into the picture, because it allows you to upload workflow definitions dynamically, so which means you don't need to redeploy your environment. So all you need to do is just call one of the OpenStack services, call its API, upload a new version of this workflow that's already attached to a certain Vitrage template to react to be triggered on some particular event. And once you understand, okay, I need to handle the situation slightly differently because something has changed in my environment, I can just upload a new version of this workflow definition to work slightly differently maybe. And it also allows you to actually define any custom logic that should be triggered based on any basically event. So it's kind of an extension point where we can define like at a user level whatever we want essentially. And it's safe because we don't need to do something that requires like admin permissions and stuff like that. So it's just fully based on like a legitimate usage of OpenStack services API. And it's also pretty helpful when you can go back and see what happened in the past. And Mistral, again, provides you with the execution history. So you can see that, okay, one day ago something was running, and here's the state of this process. And I can see all the task states and everything, all the results, and I can do some reverse engineering, like, retrospective analysis, whatever. And there are, of course, some other reasons to use Mistral. Like, for example, workflows are scalable. Like, mitigating real problems is not always easy. So it may be a complicated task that that is running for a long time. And because of that, it should be reliable. It should be fault tolerant. And it should be scalable, of course, because if it involves a lot of tasks that need to run, it needs to scale well as well. Workflows can be visualized, which is really also helpful if you're dealing with some problem mitigation, if you're not maybe too knowledgeable about internals of like scripts that you have in your environment or whatever. At least at the high level, you can see what happened just looking at the Cloudflow UI. And if you need to drill down and see some details, Mistral also allows that just by looking at the particular task that failed, right? So you don't need to understand all the process and see everything. it also, Mistral is also responsible for parallelizing things. So you can define the workflow in a way that you can do many things in parallel, and it's kind of a natural things. And basically, once you are able to represent your process, your distributed process, in the form of workflow, you can define multiple parallel branches, identify what can run in parallel. And Mistral, as an execution mechanism, is going to take care of this parallelism. So it's going to figure out the right order of executing things, and basically it will just take the burden to figure it out correctly. What's also important is, like I said before, a workflow may take long to complete. So, and if it was implemented just as a regular script, so once something crashed, the machine where the script was running, so we lose everything. So it's not stateful. We cannot see really what's already done, what's not. But the workflow mechanism allows you to basically restart from a certain point. So you see that, like, okay, my 10 first steps were running for like a day, and they were successful. So it doesn't make sense to start over. I can just start from the point where the failure happened. If I know if it makes sense now, because some environmental problem, for example, was already fixed. So, and from that perspective, it's really cool that we can restart the workflow from a certain point where it failed. One more thing is that workflow technology is responsible for basically, I said probably a few bad words about scripting, but the irony is basically that workflow allows you to wire like multiple things, including scripts, as certain steps of your workflow, so that you can actually write multiple scripts, fine. But what workflow does basically, it allows to wire all these scripts together, providing a data flow mechanism, so that one script actually produce some result, and it needs to be transferred safely to another step, which may be another script. And Mistral is that mechanism actually that allows to transfer data from one step to another and take care of parallelism and all other things. And here is some information basically about our projects, how you can reach out to us and discuss whatever, some whole pages. And I think that's it. So if you have some questions. Ifat? Ifat?
Yeah.
Yes, please.
Has this combination been used in any production environment?
To our knowledge, not yet.
Not yet? Yeah. Yeah.
Well, firstly, I think this is really awesome, so thanks for all this. What the whole process, like, so you showed in the demo, what's visible in terms of the root cause analysis and the process through the workflow. Is that equally visible to the admin and the tenant that's affected, or does the tenant see less of the information than the admin?
We support multi-tenancy. The tenant will only see the resources and alarms relevant to his own resources.
Yeah, same about workflows. So you'll see only your own workflows that you have access to.
But would you also see, as a tenant, get visibility about the underlying infrastructure? So things like the NIC on a hypervisor, even though normally like the underlying hardware is hidden from the tenant, right?
No, the tenant only sees his instances, the host, but not anything, not the NIC, not.
So the subgraph that's related to
just related
accessible
to
resources. Yeah.
Yes.
Question. So first, can we hook up any other type of monitoring
Yeah, so we have a pluggable model for that is very easy to add new monitors. We currently don't support Sensu, but we heard the requirement several times in the past, so I assume that it will be supported. And of course, it's open source. Anyone can add another monitor. It's very easy.
And
Yeah.
what could, like some of the state transition thing that you mentioned, could it not be addressed by heat? Why Mistral and not extend heat?
Okay. So why not heat? Conceptually, they are completely different, actually. They probably complement each other. So what heat is about, you can define what I want to get when the heat stack is deployed, right? So it's like the declarative description of the environment that you want to get. In Mistral, the process itself is more important. So so you may not even have any like final state that you'd like to get. So because if you're like designing a monitoring tool, there is no state. So you just need to program, define the rules how your process should behave depending on certain conditions. So like it's basically, in other words, Mistral is more like an imperative logic comparing to heat where it's declarative, where you define the state rather than like steps how to achieve that state. So like they're basically orthogonal to each other.
Could you flick back to that last slide?
Yep.
So that was really quick. No. The very last slide before Nokia. The one where you said,
This one?
find our stuff here.
Oh, okay.
Yeah.
Oh.
Is this particular integration documented anywhere? Is there kind of cookbook?
Oh, not yet.
Well, it is mentioned in the documentation of Vitrage Templates that this is one thing that you can do in the template, but there is no document of this is a best practice or something like this.
So
This is missing, yeah.
that could be our first use case.
Yeah.
First self-using.
Yeah, we came up with this really recently.
Can Vitrage do it like, we'll get a root cause and performance starts to slow on the application with regards to storage or it's the database and you've got that for you? Is it dual alarms and pre-scripted events?
Well, I'm not sure if I got the question right, but Vitrage gets alarms from whatever monitor that you have. I mean, if it's pluggable to Vitrage, and then it can do the root cause. The logic is defined in the template. So if you have your own kind of alarm, you can add it to the template, add the root cause based on your experience. Or even if you don't know the root cause and something happens and you manually understand the root cause, you can add a new template. So next time it will be a much faster process.
Actually, on that point, if you have, say, some kind of performance degradation alert, and you know, like that it affects a hypervisor host, for example, and you're also seeing some alerts for failures or performance degradation on some of the dependent resources, like instances running on that hypervisor, even though there might not be like a definite link in your templates between the two, because you don't know for sure that there's a connection. Is it possible to kind of for it to speculate on the connection, saying like, well, we know there's a problem here and there's a problem here. It's quite likely that they're related, but it's not a definite connection. Is that something that?
So when we first designed Vitrage, we considered having like a causes edge with maybe possibility or probability. We thought about it. It never got a high priority to implement. But yes, this is, I mean, you could say that there could be two possible root causes, and both of them are currently exist. So you say 50 chances this. It's interesting scenario, yeah. Yeah.
So I get the impression that all outstanding work on Mistral, making it fully resilient, seems to be done now. Is that correct? And is that also the case with Vitrage, that if either service themselves fail during this process, that they can recover the process later on?
Yeah, so what's your specific
Yeah.
question? I just,
So
you
I
said
think-
everything right, but what's the question?
So if one of the nodes running one of the Mistral services or one of the Vitrage services dies, will the whole process can recover, be resilient to that?
Yeah, so we were able to make it work with like multiple engines, so it works pretty well. So there are some known situations though where your workflow might get stuck in running state, which is not really likely, but we are aware of some situations. So we're currently making some improvements in our RPC system because it's like a typical problem when you lose a message and your database gets out of sync. So you need to do something about it. So yeah, we're working on that.
So regarding Vitrage, currently in Pike, all the information of Vitrage is in memory. We are using an in-memory graph database. So if Vitrage graph process is down, then you just start a new one and recover all the information. And right now in Queens, we are working on storing the data in a persistent database. And then we will, as part of this solution, we will also actually make the high availability work faster. So the other graph will recover from the exact data that was before it was down. Yes.
Yeah, last question, please. That's okay.
So if I want to deploy these projects tomorrow, what's the best way to do it within OpenStack?
Sorry, if we want to deploy them?
Install them within
As far as Mistral, so there are like RDO, RPMs, like many ways actually, puppets. So there's plenty of ways to deploy it actually. I'm not sure what's the best for you.
Yeah, same for Vitrage, actually.
Yeah.
It's
So they're already integrated within Triple?
Yeah, absolutely. Yeah, Triple O is heavily using Mistral now. Yeah, thank you very much.
Thank you.